Well, hello and welcome YouTube. Mr. Robinson back with yet another brand new exciting video, all math based of course, and step into my domain here, into my virtual math classroom. It is an honor and a privilege to have you here to watch me do some of my fancy work. And today I'm going to focus on the distributive property. And I'm just going to do a bunch of examples. I have like 20 something. I think a little more than 20 examples. I think 24. So I'm going to do 24 practice problems. Let's do it in less than 20 minutes even. I'll teach you a little quick thing on what the distributive property is, what it has to do with, and how we can use it, and why, and all this stuff. I'll just jump right into it though. Why not? So let's see what this whole thing's going to look like here. So the distributive property, and you can see the practice problems here. Simplifying an expression, first of all, means, get rid of the parentheses. If there's combining like terms involved, we do that. We're not going to combine like terms here. If you don't know what it is, it basically means that I can't merge this A with this 8 in any sort of way through addition, because I don't know what A is, and there's no way to make this thing any cleaner than it is. These terms are unlike each other, whereas 8 and 2 can add and make 10. And furthermore, it's going to help me explain the distributive property a little bit when I do a real numbers problem. So the distributive property is basically as follows. If you have some sort of value that is multiplied by a quantity, let's not use A there again. That's multiplied by a quantity of 2 or more terms within, and by terms I mean things separated by addition or subtraction. It is best that, well, not best, the distributive property states that I'm really multiplying the value on the outside with both of these terms in this kind of order. So this equals A times B plus A times C. That's the idea of distribution, that you can multiply the thing on the outside with every term that's on the inside. And that's because that's really what you're doing. And to make sense of it, I'm going to lend my lovely assistants, Mr. 2, 3, and 4 right here. 2 times 3 plus 4. Let's take a look at this in the two ways that you would know how to do this kind of problem. Order of operations, let's do the things inside parentheses first. 2 times 7. And then you get 14, like that. Now the other way to do it, let's try the distribution way. So let's go and distribute the 2 into the 3 and the 4. So instead we get 2 times 3 plus 2 times 4. See, that's what's happening. The 2 multiplies with both of these things. Addition in the middle, either because the 4 is positive or because you're adding. There are kind of two ways to look at it, and we'll look at both based on what signs we have here. That's the thing that might trick you up with these, the negatives. 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 indeed gives you 14 as well. Now, okay, so why does that work? In order for all this to make sense, you do have to understand really what the heck multiplication is. See, when you do 2 times 7, 2 times 7 means 2 plus 2 plus 2 plus 2 plus 2 plus 2 plus 2. Okay. When you do 2 times 3 plus 2 times 4, 2 times 3 is 2 plus 2 plus 2. Now, when you do 2 plus 2 plus 2 plus 2 times 4, 2 plus 2 plus 2 plus 2, there are 7 2's that are being added as a total result of what that is. So multiplication is a series of addition values being applied a certain number of times. Right? That's what multiplication is. So when you distribute something that's added, and it's true for subtraction as well, but when you distribute something that's closed under addition like that, when you do that multiplication, it's taking care of it in a different way. Now, why would we ever do that? Because it looked like, as you probably saw with that problem, it probably wasn't very useful for you. And look, I'm going to be running past time that I said, but I want to teach this thing. Why would we ever want to do this? Well, if we go back to the problems that we're looking at, we're going to have to do it in these particular examples because these terms can't combine. So when it comes to simplifying it and writing it out, and I want to multiply this -6 with these somehow, it does multiply with both of these, and I'm going to make that happen. So that's one reason we're going to have to do it in these cases. And it helps solve equations, especially when there's something to distribute. It does help solve equations like that. So that's one reason. Here's another reason, and it's kind of a little off base. I'll kind of talk about it in kind of just a nice way that helps you and go like, oh, I never thought about it that way. What if I told you right now, 13 times 97, do it. 13 times 97, do it mentally. You can't write anything else down. Well, you can. I'm going to write some stuff down to think about it. You're having trouble, aren't you? Well, here's what I would do. I would keep the 13 exactly as is. No problem with that 13. Keep this 13, and instead of writing 97, I'm going to write 100 minus 3. Why am I doing that? Because I know what 13 times 100 is. And I know what 13 times 3 is. 13 times 100 is 1300. 13 times 3 is 39. If I do 1300 minus 39, I get 1261. That's the answer. Now I can do that mentally. So can you. It's possible to do those ones mentally, and that's another way of coming up with the idea of distribution. Why combine these like terms when I can't do that as easily as I can do this? I'd rather do 1300 minus 39. So there are reasons and ways in which distribution kind of has its place in math, specifically with mental portions and stuff. Plus the fact that you're going to have to know it for every single math thing you do in algebra and onwards. So, you know what? Deal with it. So let's deal with it together. Let's learn what this is. And right off the bat, they deal with a negative here. And here's where it's super important because the negative gets dropped for some people at times. Let's erase all the other stuff here. Number one, negative 6 times a plus 8. Now you do distribution. Now I highly recommend that you probably just put addition in between every set of terms that you have, and you treat the signs exactly as they are. And I'm special dotting this negative 6 to tell you that make sure that negative 6 gets distributed into both of these terms, that you do not accidentally just do negative 6 for the first one, and you ignore negative 6 for the second one. Okay. Now this in between step is not one that I'm going to do the entire time, especially for the sake of time, but I'm going to multiply. I'm going to put this all in parentheses. I want you to make sense of what's going to go happen. Negative 6 is going to multiply with a, and negative 6 is going to multiply with 8. And in between is a plus because the signs will be as they need to be once I do my multiplication here. You know, if I add a negative, it becomes subtraction. So that'll take care of itself. So as long as I put plus in between, I think it makes it really kind of, it foolproofs it. It's a good thing. So negative 6 times a is negative 6a, plus negative 6 times 8 is negative 48. And adding negative 48 is subtracting 48. So that becomes negative 6a minus 48. That becomes the solution, not the solution, you didn't solve anything. That becomes the simplified version of that expression when you distribute. Now, if you know how to do that in one fell swoop in one step, that is great. I just want to make sure that you don't ignore negatives wherever they jump into play. Don't let me forget to do this side because I got to do the right side as well. Okay, number 2. Distribution. Boop, boop. Just like that. 4 times 1. Let's do it the same way as last time. 4 times 1. Notice how I'm using parentheses for the emphasis of multiplication. And it's it's for the point of if something's negative, I make sure that I kind of take care of it. Times 4 plus 9x. Plus 4 times 9x, excuse me. 4 times 1 is 4. Oh, hello. And 4 times 9x is 36x. This is a fine answer. But later you're going to be using something that's called standard form. And I'm just going to go and write it. The term with the variable, if you have a term with a variable and one with a constant, for the most part, the one with the variable is going to go first. There are exceptions to it, but I prefer looking at it like that. Maybe you do as well. Maybe you don't. Both answers are the same. Addition's commutative. That's another thing I'm stretching a principle of. 36x plus 4. If I looked at an answer key for this, it probably just says that one. Moving on. Number 3. 6 times negative 5n plus 7. 6 times the quantity, negative 5n plus 7. Distribute the 6 into negative 5n and 7. What do we get? Negative 30n plus 42. Now, you might not yet know how to do distribution with variables, and I don't like with other things, like if the 6 also had an n, and I don't think this one gets into that, which is fine. But eventually, you know, you're going to multiply the n's together, get n squared, stuff like that. But as you multiply, no like terms need to be had. You multiply a scalar with something else, the coefficient multiplies with that scalar value. 6 times a negative 5 is negative 30. Is negative 30n goes in play there, in case you weren't certain, because I think that was our second time we've seen a problem like that. Okay, now we're seeing a problem where something's on the other side right here. Well, the good news is multiplication is also commutative, meaning I could write this 2 in front, and because my OCD is kicking in, I'm just going to do that. I'll probably do it for all the ones that have that thing there. But yes, you could distribute the 2 no matter which way that it's written. But I'm going to write it on this side right here, because why not? So the 2 distributes into 9m. Let's try this one mentally. 2 times 9m are going to multiply. Well, we'll do it mentally, but with the arrows. 2 times 9m is 18m, and 2 times 10 is 20. That's the result, 18m plus 20. So it can be that easy. The tricky part is when you have negatives, and that's where you have to decide what you want to do formatting wise. And here's number 5 is a perfect example here. I only did 4 problems, jeez. Number 5. Again, I'm going to write the -8 in front because why not? Now, keep in mind, there's a dot there. This is not subtraction. This is times -8. That's why I really like the parentheses things. That's why I like it out in front. Okay. So here we go. -8 times -4 minus 3n. Here's where all the parentheses things is going to be really nice for you if you keep it that way. If I'm going to distribute the -8 into here, I'm going to do -8 times -4. And I'm going to write a plus here. I don't see a single plus here at all. But if I make sure to know that that -3n stays as a -3n when I write this portion, then it's not going to matter. Because -8 multiplies with -3n, and then the sign is going to be as it needs to be as long as I do put a plus there. This isn't the only way you should do this problem, but if you have trouble doing it any other way, I would kind of recommend doing it this way. Anyway, negatives times negatives gives you positives, and all these negatives end up giving us a result of positive answers. And I'm going to write the term with the n first just because standard form. Don't worry about it. Well, understand why I'm doing it maybe, but either answer works. Now, if I'm actually to look back at this, and I'll do it in a different color here. Let's say I wanted to do distribution the other way. Let's say I don't want to write parentheses around my negatives with my 8s, but I do have to make sure my 8 stays negative. I'll write -8 times -4. I'll still do parentheses around the -4. And I'll do the minus for the 8. I'll say -8 times -3n. That's fine. But you don't know how many people will multiply this 8 with a -3, get -24, and somehow disregard the fact that there was another minus right here when you subtract the -24 and it becomes plus 24n. How many times again? I'm saying this as a 7-year math teacher. Oh my goodness, how many times it happens. It's a careless mistake. It's something that does happen, and it's something that can be prevented, and this can help prevent that. There are other things you could do. People use this box method thing, and I'll show you that at a different time when it's a little more necessary. But you got to know how the negatives are going to come to play with that. Subtracting the negative, or that's still a -8. It's just, it's tricky. It's tricky. 8 times -b and 8. So, sometimes people do things just with these signs instead. So they're like, let's kind of do this one mentally. 8 times -b is -8b. And then you write a minus because it's there. And then you say, okay, 8 times 4 is 32. That works. That's the right answer. And that's a format, honestly, because I don't really show much work when I do things. Once you do these a lot, I'm not bragging, you're good at it. So once you find ways to cut corners and do things mentally, it's kind of what you do. I don't ignore my negatives ever that I know of. I don't forget them. And that's good. And I remember to not let students forget them too. And that's really what I'm trying to hit at. All right, you know how I want to rewrite this thing. Let's get the 5 first. So look, a lot of these problems, the problems don't necessarily get harder as we go. So if it's okay, I kind of can just show you the work and then tell you if there's something else that gets a little tricky along the way. But again, just like the last problem, what you could do is 5 times 1, and then write the minus right now, and then do 5 times 7n. So that's fine. That's a way you can go about writing that problem, and that works. And that's a fine answer. And of course, if I write it in standard form, the term with the variable would come first like that, even though it's negative. And I would probably agree. I kind of like the look of that one more, but just standard form. I'm just going to stay consistent. Let's just do that. Okay, now catch my mistake here if you can. So, okay, -6 times x is -6x, and distribute 6, so plus right there, and 6 times 4 is 24. Okay, so catch the mistake there on that one. What happened here was my -6 didn't distribute into that with the +4. It was a +6 that I multiplied there. This shouldn't be a plus. It should be a minus because the 6 is negative. It's negative for both, not just for one of them. And you might be okay to remember them here. What's going to happen eventually, and this is where I can work on this. What's going to happen eventually is if you get a problem like this, 8 minus 6 times x plus 4. Now it really gets forgotten. You know why? Because if you're going to distribute here, you'll say, hey, let's distribute Okay, so this is going to be 8 minus, and let's do 6 times x, and let's do 6 times 4. See, you wrote the minus thinking about it as an operation and less as a sign for the 6 that's being applied. You're forgetting the fact that really there is a grouping all right here that's happening because it's multiplication that comes before subtraction. So really, this happens here, and then the negative gets distributed into here, and then you get 8 minus 6x minus 24. So that becomes a minus when the negative now distributes. It's a weird thing that happens there. That becomes negative 6x minus 16, like that. So instead of plus 32. So that's not the problem. But that's when the issue arises. When there's a number in front, you kind of forget of that thing as a negative or how order of operations works with it. And again, I say this with experience of seeing it. Believe me. Believe me. Oh, it happens quite a bit. All right, let's do this one mentally. I know there's a minus there, but only one minus involved in the whole thing. Let's try that. 5 times 3 is 15. So we've got an m there, 15m. Minus, see, that's where you can get messed up maybe, but 5 times 6 is 30. You got 15m minus 30. Okay. So again, some problems faster, some problems slower. Number 10, hey, what do I want to do? Let's get that negative 4 out in front because I can. Now, maybe I should do a problem where I don't, but you still distribute the negative 4 into both. I'm going to do the old-fashioned way this time because I have a couple negatives here that I don't want to mess up. So let's just do that negative 4 times negative 6p. Let's put the plus here for old-fashioned sake. Negative 4 times positive 7. Okay? No harm in doing this every so often. That's a positive 24p, and then that's plus negative 28 becomes minus 28. The more you can do in your head or say things there, kind of the better it becomes for efficiency. I'm not promoting things that you think you're going to make mistakes with, but things you want to practice when you're able to. You don't want to, hey, let's try mental math for the first time during a test. No, you want to try it before. Do plenty of practice here. Again, distribution is in a very quick order form right here. What do you think? 5b minus 5? Yeah, 5 times b, 5 times negative 1. That's the result on that one, number 11. So again, the problems aren't really getting harder. So I mean, I can start to speed it up. I want to hit under that 20-minute mark. I have less than 3 minutes to get there. So let's keep going. Let's try to distribute this way this time. Keep in mind, I'm doing 5 times x first. 5 times x is 5x. 5 times 9 is 45. Everything's positive. My favorite, your favorite, all our favorites. Now you're seeing the distribution more. It's starting to make sense. I would normally combine like terms if I could first, but of course, no combining like terms here. See a bunch of negatives, maybe a red flag for you to say, hey, hold it. Let's go ahead and do our negative business. Negative 4 multiplies with negative 8x and with negative 8 with a plus in between if all is the same to you. I'm going to go ahead and write it that way. Make no mistake about it. A negative times a negative is a positive. Negative times a negative is a positive, and I'm going to add that positive. 32x plus 32, all set. Let's do that box again. All set. I won't finish in 1.5 minutes, but you got my goal from before. Negative 6 multiplies to both the positive and the positive. Negative 6 times 7, and see some people do this, minus 6 times x. That's fine, just keep the minus for both. But, sometimes the sign thing gets mixed up for that. That's negative 42 minus 6x. And, of course, standard form would be negative 6x minus 42. If you ever reorder things, make sure that the sign of the thing stays the same. These are both negative, so that's no issue. But, make sure that you do not make that mistake. Number 15. So again, here's where that mistake can happen. If you write negative 3 times x, and that's a minus, so you're like, oh, I remember that. Minus 3 times negative 5. You remember all this. You wrote it like there's nothing wrong with this. It's written correctly. Negative 3 times x is negative 3x. Just make sure you don't say 3 is a negative 15 minus 15 like that. This is minus a negative or negative times a negative. This will give you a positive, a plus 15. That is how that's working out when those things are written. That's why sometimes kind of putting that is just the better approach. It's safer. So, but I'm opening you up to all venues here. Keep all of those in mind. All right, negative 5 distributing into both. 5 times 10 is 50, so this is negative 50x. Negative 5 times 1 is negative 5, so negative 50x minus 5 gives you that result there through distribution. I'm just showing you all the different points. It looks like I'm not doing much different. Let me show you a box version. I'm not going to explain much to it outside of the fact that what you're doing with a box is kind of making its area. If this is kind of like a base times height thing, like your base is 1 plus 2v, and because you don't know how much they actually are, like how much 2v compares to 1, you split up that thing. And then 5 is like your height. It's like base times height, you know, kind of like that. And what's kind of nice is you multiply within these smaller rectangles here. 5 times 1 gives you this one. 5 times 2v gives you this one right here. And then these things total up to the whole area is the addition of that area plus that area, 5 plus 10v, and that's your answer. So that's the idea of it. I don't think everyone says it like rectangle or area. They say box method, grids. Better with a 3x3 or something. Better with keeping control of negatives, I'll tell you what. In fact, I'll do it with this problem again. It's weird to talk about negative height or anything like that, but if I had a negative 8 here with a 1, and keep in mind, this is a negative 5x. And again, weird to talk about length as negative. We don't know if this is negative or not, because x could be negative or 0. But we don't know. We're just simplifying. We still multiply. Negative 8 times 1 is negative 8. And check this out. You kind of remember to do the negatives here. They're written, and you see them exactly as they are. Negative 8 times a negative 5x is a positive 40x. You know to do that here, you know? So there is a benefit to that. But I wouldn't get caught in doing that every single time when you don't have to. Anyway, add those up. That's negative 8 plus 40x. And of course, as you know, I want to get this other term first, 40x minus 8. Noting that the 8 stays negative and the 40x stays positive. 6 more problems. Is that okay? Push it a little bit longer. Negative 7 times, let's do the old-fashioned way, negative 7 times 5k. I said k, but I wrote x. Negative 7 times 5k plus negative 7 times negative 4, right? That's negative 35k. I almost wrote an x again. Plus 28. I've written a lot of x's recently. I'm just kind of used to it. Okay. Okay. Let's go back to distribution here. Again, all these are distribution. Look, I'm showing all the different formats that people write them. I want to open up all different venues here. Negative 5 times 7 is negative 35a. Negative 5 times negative 6 is positive 30. So that'll be a plus 30 right here. Kind of one too many problems for me to do through the whole sample thing. But as you keep practicing, you're looking at all different options. And look, here's the easiest problem in the whole set. All the things positive, all the numbers small, no coefficient in front of your n variable. What do we got? 5n plus 30. Any objections to that one? Does that one look okay? Hopefully. Kind of getting used to that. I got 3 more. And again, pretty basic when it comes to it. You know, some people do like, let's distribute. I don't know what people do for arrows and such, but people distribute in different ways and different forms here. I got 4 times 3r minus 4 times 8, putting the minus from that one right there. That's 12r minus 32. Okay, so this distribution stuff, it's pretty commonplace. You just got to get familiar with it. That's why the practice is here. You want to know how to do it. I mean, what's wrong with doing 24 of them if you think that's going to ensure you that you're going to be getting it right the rest of the way? I don't think there's any harm in that. 3 times 5 is 15. 3 times 5x is 15x. That's your result. And of course, standard form would look like this. And the last problem right here, there's a negative 10 multiplied with 1 and 9x here. I'm going to kind of rewrite everything, not just the negative 10 in front, but I'm going to write the 9x first. You know I like standard form, so why not just get the term with x to lead off this thing right here when I start it? I think that's fair. I think that works out. Let's try it this way. Negative 10 times 9x with this minus 10 here, minus 10 times 1. See, I don't think you'll forget the minus things here because that one doesn't have a negative too, so I think you're good. That'll be negative 90x minus 10. Okay. All right, so that's the idea of distribution, and you saw kind of reasons and purposes behind them. There are great uses for them. When it comes to solving an equation, you'll see that distribution can be a first step to simplifying. Then you can end up combining like terms. You saw a mental math kind of approach thing to it as well. And you see why distribution kind of has to be when you have things that cannot combine already to start with. You're seeing different variations with the negatives, with the grid form, with drawing the arrows, some mental math, kind of getting all that big idea there. And hopefully you're getting a nice... I see an eclipse in the background. Look at that. All right, so maybe that's an omen. It was like, you're a little too late. So, all right, I'm going to wrap that one off right there. Hopefully you got some good practice there. And if you have any other questions, just go ahead and let me know. Drop a comment down below. I appreciate you stepping into Mr. Robinson's virtual math classroom. Yeah, class is dismissed now. You may have a good day or night wherever you are.